Computers' complexity and intractability from the parametric point of view. Introduction. The subject of this book is perhaps best introduced through a somewhat whimsical story. Imagine that a scientist, Dr. O, has collected a number of data points that support a new theory of some sort and is nearly ready to publish. Dr. O observed that some pairs of these observations are in conflict, although most are not. The problem naturally arises of whether there is a way to determine a minimal set of observations in the dataset that would explain all of the inconsistencies and that perhaps deserve further consideration. Because some sophistication about computational matters is now called for in most sciences, Dr. O has a nodding familiarity with the subject of computational complexity and even owns a copy of the classic book by Gary and Johnson, Computers and Intractability, a guide to the theory of NP completeness. After a bit of thought, Dr. O realizes that the problem can be modeled by dots and lines. The data points are represented by dots, and a conflict between two data points is represented by a line between the two corresponding dots. The problem is then to come up with a minimal number of dots whose removal would eliminate all the conflicts along the lines of figure 1.1. Consulting with the computer scientist who is a member of the interdisciplinary research group to which Dr. O belongs, Dr. O is informed that this is indeed a well-known problem that goes by the name of vertex cover and is NP-complete. In fact, it is one of the 6 famous and basic NP-complete problems singled out for attention by Gary and Johnson. But my dataset is pretty good, laments Dr. O. There are probably only 40 or 50 troublesome data points, maybe only 20. Apart from the fact that the problem is NP-complete and hard to approximate, all that classical computational complexity has to offer is that for every fixed value of k, there is a polynomial time algorithm to determine whether removing k-points suffices to clean up the dataset, namely the trivial brute force algorithm of trying all k-subsets. Indeed, knowing that classically the problem is NP-complete would seem to suggest that the only approach would be exhaustive search. The running time of this exhaustive search algorithm is roughly proportional to n to the k, where n is the size of the dataset. If we assume that Dr. O has between 500 and 1,000 data points, then this brute force algorithm is impractical when k is more than about 5, since the number of steps would then exceed 10 to the 15, and few realistic computations involve that much effort.